Alright, what's up guys? In this video, we're going to pick up with some calculus here. This is going to be another integration practice video. We're going to work on example number 8 today. Alright, so what we're asked to deal with is the integral dx over 1 plus x squared squared. So to evaluate this one, we will use a trig substitution. And I'm not going to go into significant detail about trig substitution in this example. If you need a thorough explanation of how to do trig substitution, the whole process, everything that comes along with it, I do have videos on Facebook, Instagram, and on my YouTube channel where we do multiple examples of evaluating integrals using trig substitution. So check out those videos, but I will give you just a general understanding of it as it pertains to this example. So the question is, which substitution do we need here? Well, this is clearly a tangent substitution. So remember that trig substitutions don't have to be under square roots, but most are. And remember, if I see the square root of x squared plus a squared, or if I see the square root of a squared plus x squared, because addition is commutative, meaning you can switch the order. Or again, if you don't see the square root at all, as long as it takes that form, then you know you use the substitution x is equal to a tangent theta. So in our particular case, we will easily see here that x is going to be equal to tangent theta. We now need to take the derivative of that. So the derivative of tangent theta is secant squared theta multiplied by d theta, and then we just take the information that we have and plug it into the integral itself. So up here we'll get secant squared theta, and then down here in our denominator I'll have 1 plus, this would be tangent squared theta, quantity squared, okay, and that's going to be integrated with respect to theta. Now we do some simplification over here on the side. So we got 1 plus tangent squared theta squared. Well, that's just secant to the 4th theta. And the reason we know that is because remember that secant squared theta is equal to 1 plus tangent squared theta. So if I replace this 1 plus tangent squared theta with secant squared theta, I would take the two powers here and multiply them, giving me to the 4th, which would be secant to the 4th of theta, or secant to the 4th theta. So now the integral just becomes secant squared theta all over secant to the 4th theta d theta. Now we know that when we're dividing and we have the same bases and we have our exponents, we subtract them. So technically this would become secant to the negative 2nd theta, which we can write as 1 over positive secant squared theta. Remember the reciprocal identity that 1 over secant theta is cosine. So that means that 1 over cosine squared, or excuse me, 1 over secant squared theta would be cosine squared theta. So the integral 1 over secant squared theta becomes cosine squared theta if we use a reciprocal identity. So now we'll convert this integral into the integral cosine squared theta d theta. Now we can use another trig identity. Remember the half angle identity, that cosine squared theta, that's just 1/2 cosine of 2 theta. So we're going to rewrite the integral. I'm going to pull out the 1/2 because that's just a constant, and then in the integrand here we'll have 1 plus cosine of 2 theta integrated with respect to theta. So remember, for the trig substitution, I oftentimes hear people say, well, all you really need to know as it pertains to I guess the trig identities or whatever is the Pythagorean identities. And yeah, that's true. I don't know how you can do trig substitution at all without having memorized those trig identity, the Pythagorean identities. But the other identities come in handy as well, because if you notice here, we're using reciprocal identities. We're using this is a half angle identity. And so the other identities also matter. So make sure you know those as well. We're going to be using those. And then we just integrate this. So this will be 1/2, which is a constant. And we integrate all of that in here with respect to theta. So that's just going to be theta. Remember that the integral of cosine of 2 theta d theta, that's 1/2 sine of 2 theta. Okay. Technically plus c, if you want to be technical with it. And we can go ahead and, expand out this expression. And if we expand that out, we'll get theta over 2 plus, 2 times 2 is 4. So we can write this as sine of 2 theta all over 4 plus c. Okay. Now remember, if we go back to our substitution, x is equal to tangent theta. Well, then that means that tangent theta is going to be equal to x over 1. And as we get another sheet, we use Pythagorean theorem here. So remember that tangent theta, that's opposite over adjacent, which means that we're missing the hypotenuse. So in our case, since tangent theta is x over 1, that means that the opposite side is x and the adjacent side is 1. And it's not explicitly required that you draw a triangle out to do the trig substitutions, but they are helpful. If I were in actual class, I probably would not draw it out. Well, it maybe depends on the time constraints or whatever. But, it's not necessary to draw a triangle, but it can be helpful to sketch it out. One thing I want to touch on very quickly before we keep in mind that if you go back to what we had over on the other side, which was sine of 2 theta, remember that sine of 2 theta, that's just 2 sine theta times cosine theta. And we know that sine theta, in terms of the ratio, is the opposite side over the hypotenuse. And we also know that the cosine theta is adjacent over hypotenuse. And so the reason why we need the hypotenuse is because since we know that sine of 2 theta is 2 times sine theta cosine theta, we need the hypotenuse to figure out what the ratio for sine and cosine is. So if we go back, remember that a squared plus b squared is equal to c squared. So we already have the opposite side, we have the adjacent side. So if we use Pythagorean theorem, this would be x squared plus 1 is equal to c squared. And if we solve for c, we'll take the square root of both sides, thus giving us c is equal to the square root of x squared plus 1. Keep in mind, c is equal to the square root of 1 plus x squared is the exact same thing because addition is commutative. So x squared plus 1, that's the same thing as 1 plus x squared. Just want to make you aware of that. And now having all the information that we need, we know that the c would be the hypotenuse, which is the longest side of the triangle. It's the side of the triangle that's directly across from the right angle. We know that the adjacent side will be 1, the opposite side will be x, and we now have our hypotenuse, which again is 1 plus, or the square root of 1 plus x squared, which again is the same thing as the square root of x squared plus 1. And so now when we go back to our sine and cosine, we got sine theta is equal to, if we use the information, we got x over the square root of 1 plus x squared, and cosine theta will be 1 over the square root of 1 plus x squared. Now remember that if we go back to what we had here, again, we went ahead and expanded out. And when I say expanded, I just distributed in the 1/2 to everything inside. But 2 times 2 is obviously 4. So you can imagine that you pull a 1/4 out, and that'll leave you with sine of 2 theta. So in a sense, if I had pulled out the 1/4, or if we have 1/4 sine of 2 theta, Now we know if we change it up here, we'll have 1/2 times the, if we look at our ratios, which was, again, sine was x over the square root of 1 plus x squared, cosine was 1 over the square root of 1 plus x squared. So this would be 1/2 times x over the square root of 1 plus x squared times 1 over the square root of 1 plus x squared. And we expand this out. So this would be x over 2 multiplied by 1 plus x squared. Okay. All right. So with all that information, we pretty much have everything we need to solve the integral now, or write our answer down. Now let's just quickly go back up here. Much like for u substitution, we need to convert back to the original variable. So if x was equal to tangent theta, again, we need to find out what theta is. And so that means that theta is going to be equal to arctan, or tan to the negative first of x. So this would be tan to the negative first of x, or arctan, however you choose to write it. And so for our final answer, all we have to do is plug in the appropriate information. So for our final answer, for the integral dx over 1 plus x squared, quantity squared, the answer to this integral would just be 1/2 arctan, or tan to the negative first of x, plus x over 2 multiplied by 1 plus x squared. And then you need to tackle on a plus c for your answer. And that's the solution. So that was integration practice example number 8. Again, this was a trig substitution. So if you still need help with trig substitution, I have plenty of videos on that. So check out those videos. But that's going to be it for this video. And I will see y'all next time. Let me know if you got any questions about how everything was done. Y'all take care.